Welcome to today's GATE video. Myself Dr.R.MADHANA, SA Engineering College, Assistant Professor from EEE Department. So first, today I am just going to explain about the single phase induction motor. Let me go to the presentation. So what is single phase induction motor? So it is nothing but one of the most widely used induction motor in electrical machines as well as the household purposes. It is working under the principle of electromagnetic induction, and when compared with the other motors, it has the very good performance and very high efficiency. Okay, so it does not require any electrical contact between the stator and the rotor, and it has the unique construction when compared with the another motors, so that it has the better reliable operation and also efficiency is minimal operations and maintenance also very less. Okay, so before going to the single phase induction motor principle and operations, why it is not self-starting, we have to know that. So we have the answer for that. So it is nothing but it has the stator. So stator is wound with a single phase winding. So whenever the supply is given to the stator, it is producing the alternating flux. So what will happen? The alternating flux act as the squirrel cage rotor. It cannot produce the rotation. Only the revolving flux can produce the rotation. So that is why the single phase induction motor is not the self-starting. Okay, let me see the operations of the single phase induction motor. So as I said in previous slide, it is working under the principle of electromagnetic induction. It works by mainly the electrical energy is converted into mechanical energy, okay, by the principle, and also it can be described in the two methods. First one is double revolve field theory and next one is cross field theory. So let me discuss about the double field revolve theory. So in a double revolving field theory, it is formulated by the Ferrari. The main purpose is in the single pulsating magnetic field, as its maximum value can be resolved into two rotating magnetic fields of their magnitude rotating on opposite direction at a synchronous speed proportional to the frequency of the pulsating magnetic field. This describes the double field revolving theory. And cross field theory, can generate the rotating magnetic field and produce the torque. So which means that what will happen, the interaction between the stator and rotor magnetic fields, so that the resulting will happen revolving field that allows the rotor to start and rotate. Okay, yes. So continuation of that, the construction of the single phase induction motor we can going to see here. So here I have mentioned the construction. We can see the important parts of the single phase induction motor. It is nothing but here the bearing is placed, end of the place the motor shaft is placed, and these are all the two main parts. It's nothing but stator and the rotor. So in between the stator and rotor, the armature winding is near to the rotor and stator winding is placed near to the stator. So near to the rotor, the end bracket bearing housing is placed, end of that cooling fan is placed. Okay, so corner of the construction, the yoke is placed. Okay, so then the single phase induction motor, as I discussed in the construction, it has the main two parts, right? So first one is stator, another one is rotor. So first main part, stator, is having the core laminated part. Okay, inside that core it has the copper winding. It is for the purpose of reducing the energy losses. Okay, and also it will use for the alternating current flows for the circuit. Fine. So it is responsible for the mainly for creating the magnetic field in the rotor spin. Fine. So next one is rotor. So it is the another part of the single phase induction motor. Here it is made up of a copper or aluminium. It is connected to the ends by the rings. Then these bars are closed loop, so that the magnetic field from the stator interacts with the rotor. So that it induces the current in these bars, which causes the rotor to spin. That means rotate. The motor also includes the shaft connected to the rotor bearings to support the shaft for the purpose of smooth connect with the rotating part of the rotor. Fine. So it will finally the shaft is closing the circuit, that means rotor part. What will happen means it will frame the circuit to hold everything together. Fine. Yes. So it has the starting torque. So in the single phase induction motor, having the torque is 0 of the pulsating single phase magnetic flux. So motor requires the generation of the rotating magnetic flux. So to the similar to the rotating flux in the 3-phase alternator, that means 3-phase motor. So here it has the 2 perpendicular coils that have a currents 90 degree out of phase. It can generate the necessary rotating magnetic field in the which start the motor. Okay, so therefore the single phase induction motor are built with the 2 perpendicular windings. It is nothing but the stator windings. It is called as the auxiliary winding. Another one is rotor winding, that is called as the main winding or run winding. So this phase shift is here, the induction motor achieving the phase shift. It can be connected by using the resistance, inductance as well as the capacitance. So most frequently we used the capacitors for generating the starting torque. So the single phase induction motor having the types that can be classified here. So let me discuss about that. So first one is split phase induction motor and next one is capacitor motors. So capacitor motors having the sub classifications. It is nothing but capacitor start induction motor, capacitor run induction motor, and third one is capacitor start and capacitor run induction motor. So another one is shaded pole induction motors. So we are going to discuss about this classifications. So first one is split phase induction motor. So it has the 2 windings. It is nothing but, it is similar to the single phase induction motor normally. It has the 2 windings. It is nothing but main winding and another one is auxiliary winding. So it has the phase angle is nothing but 90 degree. We can see in the phasor diagram as well. And in main winding it has the low resistance and high reactance. As well as in auxiliary winding we have the high resistance and low reactance. Okay, the switch is equal to the motor pickup and it starts with the 75% of the rate of speed. So here I have shown the split phase induction motor. We can see here the supply is given in the initial part of the circuit, single phase supply is given and main winding is mentioned here, the switch is placed here. This is the nothing but auxiliary winding. Here the phasor winding I have shown. So it has the characteristics and applications that I have mentioned here. So starting torque of the split phase is 1.5 to 5 times to 2 times of the full load torque. The starting current is 6 to 8 times of the full load current and the efficiency is always 60 to 65% and the operating power factor is always 0.5 to 0.6. Okay, the power rating of the system is 1/6 to 1/3 horsepower. The speed of the system is 1440 RPM. Okay, it has the applications like it is a low starting current and moderate in starting torque, and it is mostly used for the easily started loads and typical applications like a fan, saws, washing machines, grinders, blowers, etc. So similarly, next we will going to see about the capacitor types induction motor. In that, first we are going to discuss about the capacitor start motor. So capacitor start motor, it has the electrolytic capacitor. Okay, so that here we can see the starting winding, centrifugal switch, and main winding, squirrel cage motor. This is the phasor diagram. So here the IM lags with voltage due to the high reactance of the main winding. Okay, then due to the capacitor, the IS, it is nothing but starting current is leads with the voltage. Okay, so then the angle is what will achieve means 80 degree to 90 degree. The torque of the system is high starting torque in the capacitor start motor. Then it has the characteristics as well as the applications. Similarly, we have seen in the split phase, it has a starting torque 3.5 to 4.5 times, and the angle varies from the 30 to 80 degree. Starting torque can be improved based on the process and performance. The power factor varies from the 0.6 to 0.75 in a capacitor start, and then efficiency is 65 to 70 percentage, as well as the power rating is 1 by 8 to 3 by 4 horsepower. So the application of the capacitor starters, it has the high starting torque, and also it is used for a hard start loads. Hard start loads only we can use this capacitor one. So it is nothing but pumps, compressor and refrigeration units, conveyors, as well as the certain machine tools. Yes, yes. Followed by this capacitor run motors. So it is there is no electrolytic capacitor. So a permanent capacitor is connected in series. In this structure you can able to see series capacitor has been connected for the starting windings. Okay, the rating of the starting winding and running winding is equal in this capacitor run motor, and the starting torque is low in this capacitor run motor. So it has the characteristics like a starting torque is very lower, between the ranges 50 to 100 percentage of the full load torque, and the power factor is high. It is varies from 0.7 to 0.8, and efficiency is always 75 to 80 percentage nearly. And applications for this capacitor run motor is used in a ceiling fan and coolers, table fan, as well as the domestic appliances. Then third one is capacitor start and capacitor run induction motor. Here we are using the two capacitors in the circuit. So which one is in these two capacitors? First one is used for improving the performance of the system, and another one is used to increase the power factor of the system while the motor is running. So here the CS is starting capacitor in series with the auxiliary winding. Here you can able to see auxiliary winding, the capacitor is placed in a series. Okay, it is used to have a phase displacement between the main winding as well as the auxiliary winding. Okay, it is nearly the 90 degree or above 90 degree phase displacement is achieved in the capacitor start and capacitor run induction motor. Okay, yes. So third one is before going to third one, shaded pole, it has the characteristics as well as the applications. Starting torque of the system is 3 to 3.5 times of the full load torque, and the efficiency is improved in this system, and power factor is 0.9 approximately. The pull out torque is up to 26, that means 260 percentage of the rated torque. So let me discuss about the applications. It is combines the advantages of capacitor run and capacitor start performance magnetic capacitors. Okay, and it is used for a hard to start loads such as the compressors, conveyors, refrigerators, pumps, etc. So these motors are often employed requiring for a quick operating motors such as hospitals and studios, etc. So the next one is we are going to discuss about the shaded pole induction motors. It is the type of the single phase induction motor. It uses a copper ring, so it is called shading coil. Okay, fine. It is used to create a rotating magnetic field so that it is enabling to start the what without requiring a separate starting winding. Okay, so it is very simple and inexpensive comparing to the previous induction motors. So it is making it suitable for a low power applications, but it also have a low efficiency and starting torque is low. Okay, here we can see the shaded pole induction motor. It has this main components like a stator, and here the AC supply is given to the circuit, and shaded pole between the poles are mentioned here, and shaded coil, and main pole is placed here, and the slot is placed in this point, and shading coil, it is made up of copper wire, and shaded pole between the poles, and the rotor is placed here. Finally, here the main pole is mentioned in the two places. Fine. So continuation of this, it has the characteristics like a low starting torque. It is between the 0.4 to 0.8 for the full load torques. efficiency is less comparing to the other synchronous motor. It is nothing but 35% of the system. So power factor is very poor in this system, 0.45 only, and pull out torque is 15% of the full load torque. Okay, the power rating of the system is 1/300 to 1/20 horse speed. That means horsepower. So applications of the system is poor starting torque and low power factor, and the poor efficiency also poor. So it has the such motors like applications. It is nothing but toys, portable fans, and electric clocks, and hair dryers, slide projectors, and humidifiers, and small business machines such as photocopying machines, vending machines, advertising displays, etc. So according to this title, let me discuss about some previous year question papers questions. Okay, it is very simple and it is easy to understand as well. Okay, before that, as we discussed in this full classes, the applications I have mentioned some of here. It is nothing but mainly it is used in the applications like household applications, like fan, refrigerator, and washing machines. And this circuit is only requires one phase power supply, and it is typically used for smaller loads. And however, the single phase induction motors are not self-starting, as I explained in the beginning itself, and so it does not require an auxiliary mechanism like a starting capacitor or split phase to initiate the motion. Okay, so let me see the problems. So first here I have mentioned the single phase induction motor is not self-starting because in this section I have mentioned you, because what is the purpose? The stator does not produce a rotating magnetic field, the rotor is heavy, it has more iron loss, it has more copper loss. So the main thing is the stator does not require, that means does not produce a rotating magnetic field. This is the reason. So I have given the solution for that. You can go on through that. Next one is the torque speed characteristics of a single phase induction motor is explained by Blunder's the theorem, double revolving field theorem, and two field theory, none of this. So we have discussed in the session. So what I have told, it has the two method, and one is double field revolving theory, another one is cross field theory. So here it is the double revolving field theory. Okay. Yes. Third one is here the simple problem I have mentioned. A 230 volt 50 Hz single phase induction motor has a main winding impedance of a 4 plus J2 ohm and an auxiliary winding impedance is 6 plus J10. What is the phase angle between the currents in main and auxiliary windings? So here are some options are there: 15.94, 24.23, 30.96, 45. Okay, so we have to solve by this way. Okay, we have to take the values as the main windings, auxiliary winding they have given. So we have to write that, and for calculating the phase angle, these are all the formula I have mentioned here. Okay, we have to apply in this. After that you will get the answer 32.47, but in options we have the values 30.96. So in some cases you can choose the answer which one is nearly to that value, calculate value. So here I am getting the 32.47, but here it is the 30.96. For rounding off you can choose that one near that value. Yes, fine. So next one is, which of the following single phase induction motors has the starting torque? Okay, highest starting torque. So split phase induction motor, capacitor start motor, capacitor run motor, and shaded pole motor. You can listen in this session itself. Capacitor start motor having the highest starting torque. Okay, so you can choose that one. It is the option B1. And last question, shaded pole motor is used in ceiling fan, refrigeration, washing machine, pumps. Exactly, the answer is B, refrigerator. We know the answer. Okay. Thank you. Thank you so much for your cooperation. Let me discuss in the second class. continue session. Thank you.